There are 2 points A and B, and the A are 2, 2, and the B will going to be 4, 2. Solve for a range of A which makes y is equal to ax squared plus 2ax plus 8 minus 2 passes through the segment AB. First of all, let's think about the 2 cases of our quadratic function. And both of the cases were going to be defined by our leading coefficient, which we usually notated as A. The first case will going to be when the leading coefficient A is greater than 0, which means when our leading coefficient is positive value, the graph of our quadratic functions opens or goes upward. When a quadratic function's graph opens upward, for example, it will look something like this that keeps going toward upward and never intersects at a specific one point. But then it will going to contain one point on our quadratic function, which is one of the most important things in our quadratic function, which we usually notated as the minimum point or the lowest point on our graph. And this will occur when our A value is positive value. The second type of our quadratic function will going to be the case when our A value, our leading coefficient, is less than 0. Which means when it is negative value, the graph of a quadratic function will open downward. When the graph of a quadratic function opens downward, which means, for example, it will look something like this that keeps going toward upward and never intersects at a specific one point. But then it will contain one specific point on our quadratic function, which is also one of the most important things on our graph, which we usually notated as the maximum point or the highest point on our quadratic function. And this will occur when our A value is less than 0. In order to solve for this question, we need to think about how to solve the vertex of our quadratic function. Now, if you think about what does it mean by vertex, the definition of a vertex through this property, we can see that vertex is the addition of the number of possibilities between the minimum point and the maximum point. If you add both maximum point and the minimum point's number of possibilities, it will going to contain our vertex. And if you go back to our question, we can realize that these questions are all about the graph of our quadratic functions. And the most important thing when it comes to graphing the quadratic function will going to be the vertex of our function. And revert the vertex's definition through our properties right over here. In order to solve for a vertex, first of all, we need to convert this standard form into a vertex form. But now we need to think about what the standard form looks like before we think about how to convert the vertex. Standard form, it is a term such as y is equal to ax squared plus bx plus c. Now let's think about what does each variable does. First of all, let's think about what the a does. A is exactly the same thing that we did or put right over here, which will going to be a term that defines our types of our graph, which is also a leading coefficient. A leading coefficient. There are lots of coefficients, and if you don't know what does it mean by coefficient, we can also review it here. Coefficient means it is in numbers, just a normal numbers like integers with variables. This is what the coefficient look like. But there are lots of coefficients, but then there is a difference between A, which is our leading coefficient, and just a normal coefficient. It will going to be a term leading. Our leading will going to be highest power term. So highest degree over a power term. Which means in our quadratic function, the highest variable term will going to be x squared. So a value should always be a leading coefficient, the coefficient of our leading highest power term, which will going to be x squared. Now let's think about the second case. The second case will going to be what the c is. If you think about what the c is, it will going to be a y-intercept. if we convert y-intercepts into our coordinate, just normal coordinate, it will going to be 0, comma, y. Which means when our input, our x value is equal to 0, our y value exists. But the reason why we just wrote it as y value, not a specific value, is because y and the x values changes all the time, which means there are variables. X and y are variables. So this will going to be y-intercepts. Let's think about the reason. So all we have to do is we can simply input our x value as 0 into our standard form, for example. If we input 0 to our standard form, it will look something like this. So it will turn into y is equal to a times 0 squared plus b0 plus c. Which means when our x value is equal to 0, this whole terms cancels at 0. And we're only going to have, when the x value is equal to 0, our y value, which we're going to be c in this case. This is what the y-intercept will look like. Now, let's think about the most important and the common thing in our quadratic function. What is the x and y? So first of all, let's think about what the x is look like. The x should always be the input of specific function, which means we input some specific values to our original functions, but then it should contain a specific thing since we knew that we inputted input. We call it as the output of a function and we notate it as the y value. So now we can relate this to our basic format or the basic definition of a function. The function always is seen that is a relationship or the expressions between y and an x, which means we can notate it in this way. It is an expression y to x. But if you think about what our quadratic function will look like, quadratic function means there are a secondary power term in our function, which means not a y value or a x value has our second degree power term. Now let's think about what the function definition will look like. Function is a stuff that always requires a specific input. And for that input, we usually notate it as the x value. But then, since we input some specific values into our function, it should generate some stuff. And we usually call it as the output of our function. And for that output, we usually notate it as the y or f of x. This is what the basic structure of the function will look like. And now let's think about what the vertex, how to solve for the vertex. The first way to solve vertex is convert into a vertex form. And if you think about the basic format of our vertex form, and is always related to our standard form, it will going to be y is equal to a times x minus p squared plus q. And if you think about what does each variable does, first of all, for the a, right over here, and we have think about the a value all the time. A value should always be exactly the same with other values from our standard form or the binomial form. A value, it will going to be the leading coefficient. The leading coefficient, which means the coefficient of our highest degree power term, and also define the types of our vertex and our graphs. Now let's think about what the p will look like. P right over here, and for the p is a x value or the x coordinate. P is a x coordinate of a vertex. Let's think about the last one, what the q will look like. And the last one will going to be q, And we can see that q is a number without any variables. So q is a value without any variables, which means it can be numbers but not coefficients. Now let's think about what the numbers without variables in one word. It will going to be a constant. And a constant, so this will going to be a constant. Constant means it is just a normal number, a natural number, or some stuff without any variables. And let's go back to our actual what does q look like. The q is going to be our y coordinate, which means the output of our function in our vertex. So this is what the basic structure of our vertex formula look like. Now let's think about how to solve for the vertex form from a standard form. So in order to solve for the vertex form from the standard form, and if you go back to our standard form basic structure, y is equal to ax squared plus bx plus c, all you have to do is we need to complete the square, which means we're going to convert this into a perfect square form. So we're converting this into a perfect square form. And a perfect square form will going to be the same thing with converting this into a completing the square. Completing a square. This will going to be how to convert the standard form into a vertex form. But first, let's write our standard format, our quadratic function down. It will going to be y is equal to ax squared plus 2ax plus a minus 2. And our ultimate goal in this question is to solve for our range. So our ultimate goal will going to be solve for the range of a. So first of all, we need to convert this into a vertex form. The reason is because we know that another way to solve for this is a formula that we talked about in a lot of videos, but then the formula in this case will going to be hard to use. The reason is because there are too many variables in it. So simply, we can use our vertex form instead. So first of all, let's complete our square. And before that, we're only caring about the a terms and the input values when it comes to converting this into a vertex form, which means completing the square. So at first, let's divide whole terms by a. We're going to be x squared plus 2x plus 1. And we still have our constant. Our constant will going to be negative 2. And from here, we can convert x squared plus 2x plus 1 into a perfect square form. It will going to be a times x plus 1 squared, and then we still have our constant left, minus 2. Now, all I did was we converted this into a simple vertex form by completing the square. And the reason why vertex form, and there should be obviously going to be y, which will going to be our output of our function. The reason why vertex form is great when it comes to solving for the vertex of our function is because it is the easiest form for us to find the vertex of a quadratic function. The reason is because the constant in a vertex form is our y coordinate as we have proved it here, and our p-value will going to be our x value. So using this term, let's find our vertex of a quadratic function. P-value should always be the term that makes this whole expression into 0, which means our p-value, we know that p comma q will going to be our vertex, and our vertex of our quadratic functions will going to be -1, and our constant, which is -2, will going to be our y output value. So -1, -2 was our final vertex coordinate of our quadratic function. As we can see, our vertex of our quadratic function was -1, comma, negative 2. And since we knew that our a value was a positive value, our graph of a quadratic function will open upward, which means as we can prove our property here, it will going to contain a specific one point, which is one of the most important points in our quadratic function, which we call it as the minimum or the lowest point on our graph. So from here, we need to solve for our a value. The a's value is the range of our quadratic function, which makes this whole expression passes through our 2 points. And for our 2 points, the first point was the a point, which was 4, so it was 2, 2. And the second point that should pass through our coordinate or our parabola was 4, 2. So our quadratic function, which goes upward and contains a minimum point, should passes through these 2 points A and B. When it comes to solving for the range or the variable in our quadratic function, we use our property, we can say the logic, which will going to be input and the output of our function. And if you think about what our input and our output will going to be, since we input, the input of our quadratic functions are always specific, which means they're going to be defined all the time. If we input our specific input to our output of our function, you're going to isolate. So this will going to isolate the variables. So we're going to isolate the variables with numbers or the integers. So all you have to do is we need to solve for it by using elimination equation or some other properties. So first of all, let's input our a value as 2, 2 into our vertex form that we converted. And our vertex form that we converted was y, which is our output of our function. We're going to be y is equal to a times x plus 1 squared then minus 2. And we could figure out that negative 1, comma, negative 2 was our vertex of our quadratic function. And this is related to our vertex form. And if we input our a value first to our function, when the a value will going to be 2, 2, if we express this expression, it will going to be when our x value, our input of our function is equal to 2, our total output of our function, which we notated as y, will going to be 2. So let's input our value as 2, which will going to be a times 2 plus 1 squared minus 2. And the reason why we convert this into a vertex form other than the vertex is because if you just solve for this using our standard form, which is our original term, y is equal to ax squared plus 2ax plus a minus 2, it contains so many variables that we're going to be confused. So we simply convert this into our vertex form, which made this less variables that made us calculate easier. So first of all, if we input 2 into our vertex form, it will going to be y, but then our y input of our function will turn into 2. So 2 is equal to a times, instead of x value, we input 2, 2 plus 1 squared minus 2. And from here, we can do one thing. We can even simplify this even further. 2 is equal to a times 2 plus 1 is equal to 3 squared will turn into 9, and then minus 2. And from here, 8 times 9 will turn into 9a. And we can get that 2 is equal to 9a minus 2. All you have to do in order to isolate our a value is simply add 2 to the both sides. If you do it, we're going to get 4 is equal to 9a. All you have to do in order to solve for our a value is divide whole terms by 9 in order to isolate it. And then we're going to get a is equal to 4 over 9. we could solve for the 1a value, but the reason why they told us to solve for our range instead of the actual value of our a value was because there were going to be the two cases where a is equal to 4/9. Another case when we input our x or output of our function as the second b point. So we could see that our b point was 4,2. Only thing that was different from the point A was that if our x value is equal to 4, our y value was equal to 2. Difference between A and B was our x coordinate. So from here, let's input 4 as our x value. If we do it, we're going to get A times 4. Instead of the x value, we input 4, and we're going to get 5 squared and minus 2. And there will obviously going to be the specific input as we generate the input, and our input y we're going to be replaced by our 2 according to our coordinate. So right over here, all we have to do is we need to isolate our specific value, and also we need to simply input this value simplified. 8 times 5 squared was 25. Minus 2, instead of minus 2, we can add 2 to the both sides in order to isolate our a term. From here, 8 times 25 we're gonna be cancelled out as 25. A is equal to 4. From here, in order to solve for our a value, all we have to do is we need to divide whole terms by 25. And we're going to get a value is equal to 4/25. And if you think about the range of our function, the range of our function will going to be answer, and that will going to be a in the middle, and then a can be either greater or equal to the last one, which will going to be 4/9 or 4/25. But then it can be either less or equal to our second term, which will going to be 4/9. This will going to be our total answer. The reason why it is greater or equal or less or equal is because these 2 points, A and B, should pass through our parabola. So the a value beside these 2 points will going to pass through our coordinate, or the parabola. So if you review what we did here, first of all, we kind of think about the 2 types of our graph and our vertex, and what we're going to define by. And we also thought about what the vertex definition was going to be. It is a number of possibilities addition between the minimum and the maximum point. And we compare the standard form and the vertex form and what is more convenient in order to solve for a vertex of a quadratic function, and also its variables work or jobs. And we could figure out that if we complete our square, which means if we make it into a perfect square form from our standard form, we could get our vertex form. And then the reason why we converted into a vertex form was because from our standard form there were too many vertexes or variables that we need to think about. But then if we convert this into a vertex form, there's only one variable that we had to think about, which was going to be a. So we convert it into a vertex form and we solve for our that our graph of a quadratic function will opens upward. It will only contain a minimum point. Minimum point was -1, -2. So for our variable, we used our variable term input and output in order to solve for our points and the range of a quadratic function, because if we input a specific value to our original function, you're going to generate a specific output with variables, and all you have to do is isolate the variable in order to solve for it. So we saw there were 2 cases where we input a and the b point. So our range of a quadratic function was that our a value can be either equal or greater than 4/25, and then less or equal to 4/9.